This is the comprehension related to chemical kinetics. When you read this comprehension carefully, you can clearly understand that 40 kilojoules is the normal energy of the reactants and 20 kilojoules is the normal energy of the products. And the uncatalyzed reaction is carried out at 500 Kelvin, whose threshold energy is 140 kilojoules. Whereas the reaction is carried out in presence of a positive catalyst at a temperature of 300 Kelvin. So this is the data given in the comprehension. We need to find out the amount of energy lowered down by the presence of positive catalyst. So let us go back to the comprehension and see how to solve this. Here it is very clearly given that the uncatalyzed reaction is carried out at 500 Kelvin and the catalyzed reaction is carried out at 300 Kelvin. So here we need to relate the activation energy at two different temperatures, and that is possible only by the Arrhenius equation. And what is that Arrhenius equation? It is nothing but K equal to A into e power minus EA by RT, where K is the rate constant, A is the frequency factor or the collision frequency, and EA indicates the activation energy, and you know the meaning of R and T. So the rate constant for the catalyzed reaction we can write like this: K catalyzed is equal to A into e power minus activation energy of the catalyzed upon RT. Whereas the rate constant of the uncatalyzed reaction we can write like this: K uncatalyzed is equal to A into e power minus activation energy of the uncatalyzed reaction upon RT. And it's given in the comprehension itself that the rate of catalyzed reaction becomes equal to the rate of the uncatalyzed reaction. So we can equate both of them. We get like this. And after cancelling the common terms, activation energy of the catalyzed reaction upon R into temperature, the catalyzed reaction is carried out at 300 Kelvin into 300 is equal to activation energy of the uncatalyzed reaction upon R into, and the uncatalyzed reaction is carried out at 500 Kelvin. So activation energy of the catalyzed reaction is equal to 3 by 5 of activation energy of uncatalyzed reaction. So here we got one more unknown, that is the activation energy of the uncatalyzed reaction. Again we can use the same formula as that of the first objective, that is the threshold energy is equal to energy of the normal molecules plus activation energy, and we know that the threshold energy is equal to 140, and as we are talking about the forward reaction here, and the normal energy of the reactants is given as 40, so this becomes 40, and now we get the activation energy for the catalyzed forward reaction as 100, isn't it? This is 100 kilojoules. So substitute this value here. So this is equal to 3 by 5 of 100, and this value is equal to 60 kilojoules. And what is the 60 kilojoules? It is the activation energy of the catalyzed reaction. And what is the activation energy of the uncatalyzed reaction? It is nothing but equal to 100. So the energy lowered by catalyst, this is equal to 100 minus 60, that is equal to 40 kilojoules. So our answer is option C.